Hello, you are welcome once again to New Focused Approach to Mathematics Basic 9. This is revised edition. And in this lesson, we are looking at solving problems involving probability of dependent events. Remember, in our previous lesson, we were looking at dependent events in general. Okay, so now we want to solve more questions and see how it goes. Let's take one example. A fruit bowl contains 3 apples and 5 oranges. Could you select a fruit at random and eat it? His sister Afi then selects a fruit for herself. Find the probability that both fruits selected are apples, and Kojo selects an orange and Afi selects an apple. Now, if you look at the question very well, you could see that once they say Kojo select the fruit and eat it, it means that there's no replacement. And so what goes into his mouth cannot come back, so no replacement. And so it means that the probability of picking the second one would depend on the first one, which makes it a dependent event. Now, from the question, we know that let A be the apple. So number of apple we say is 3 here. Number of oranges, let's use O for it, and that is 5. In that case, our sample space become 8. So the first question says that we should find the probability that if they pick at random, one after the other, both fruits selected will be apple. That means probability of picking the first to be apple by what Kojo did, okay, and probability of picking the second also what Afi did will be apple as well. And so what is the probability of picking the first being apple? We have 3 apples in all divided by the total sample space, or the number of the sample space. Then we multiply by, now after Kojo picked 1 apple and he has eaten it, we are left with 2 apples here. In that case, total fruit will be 7. And so if Afi is to pick the second one also to pick the same apple, there is going to be 2 over 7. Now we can simplify this to make it 3 times, this is 6, divided by 56. Of course, this can be reduced to the lowest form. Since the 2 numbers are even numbers, I can divide both by 3. Here, 2 can divide 6 as 3, and 2 can divide 56 as 28. Right. So that is the answer. Now, for the second question, if the 2 selected fruits, one is orange and one is apple. Okay, so Kofi select an orange and Afi select apple. So here we say probability of orange and apple. That should be and apple. Okay. So let me clean this part and then we see what we can do with the second part. Now the second part, according to the question, could you select orange? So the probability of selecting orange become 5 over 8. And here he will eat the orange, okay, because whatever fruit he selects, he eats it. That was what the question said from the beginning. And so he will eat the orange. Now Afi also went in to select, and Afi's own is apple. So apple, we have 3 apples in the basket over total number of fruits, which this time around is no longer 8 but rather 7, and that becomes the answer. And so we can multiply 3, 5, 15 divided by 56. And since we can't have a number that can divide both the numerator and the denominator, we leave the answer as such. The only number that can divide is 1, and 1 will still give us the same thing, so nothing changes. Let's take another example and see. There are 4 black pens and 4 blue pens and 4 black pens, 4 blue pens, and 2 red pens in the pack. Maria takes at random a pen from the pack, notes the color, and gives it to a student. Work out the probability she selects 2 pens of the same color. Okay, So here we have number of blue pens, or sorry, number of black pens. Let me use B for black pens. Number of red pens is 2, and number of blue pens is 4. So because we have BB here, I'm trying to write the blue as blue, then the B first one becomes the black. Now, the probability is to, before the sample space is going to give us 10 because we are looking at 4 plus 2 plus 4. So now the question is asking us to find the probability that the 2 pens selected, they are of the same color. So is this. Now the 2 pens selected of the same color means that we are going to find probability of the first one being black, and the second one also being black. So the first is black, second is black. Or, and here or means plus. Okay, take note of that. Or means plus. Or the first is red and the second also is red. Or the first is blue, okay, and the second is also blue. Right. So let's do the calculation. Now the first being black means that we have probability of black 4/10, and the second being, and remember they said, and because they said he takes the pen and gives it to the student, that means he takes the pen and give it to the student. That means there's no replacement, right? And because there's no replacement, the first is picked as blue and black, so 4/10. The second is going to be also black, so 3/9. Or the first being red means 2/10, and the second will be 1/9. Or the first being blue, which is 4/10, times the second being 3/9. So these are the possible outcomes. So we can do simple calculation here to get our answer. So the simple calculation will give us 12/90 plus 2/90 plus 12/90 again. Now we are going to add all the numerators together because they are of the same denominator. So 12 plus 12 is 24 plus 2, 20. So we have 26 divided by 90, which can be reduced to the lowest form as, so 13/45, and that becomes the answer, right? Now let's take the last example. A bag contains 5 red pens, 7 blue pens. The pens are selected by Fifi one after the other without replacement. Find the probability that the pens are of 1, the same color, and 2, of different color. The number of red has been defined as 5, number of blue has been defined as 7. Total sample space will give us 12. Now the question wants us to find the probability that when we pick one after the other without replacement, both will have the same color. So if both of the same color, it means that either the first one, we have probability of picking the first one being red, okay, and the second one being also red. Or means plus again, probability of the first one being blue and the second one also being blue, so B2. So when we make substitution, we can have first one being red means 5/7 times 5/12 times the second one being red also be 4/11 plus, that is all, the first one is blue over 12 and the second one is the same blue over 11. Now if you do all this simple calculation, your final answer should come as 62/131. Then the second question says they are different colors. Different colors means that, let me start from here. Probability of the first being red, okay, and the second is blue, or first being blue rather, and the second being red. Okay, so that comes in different formats. So the first one being red means 5 on 12 times second being blue means 7 on 11 plus first being blue means 7 on 12 times second being blue means 6 on 11. No, rather blue. So blue is 5 rather on 11. 5 rather on 11. So now when we simplify this and do it very well, this first portion will give us 35 on 131. That is 5 times 7 is 35, and then 11 times 12 is that. Plus, then 7 times 5 is still 35, and 12 times 11 is 131. When you put all together, that will give us 70 divided by 131. All right, so you can go ahead and solve more questions on your own, okay? And I'm sure this method really has helped you to understand the concept of dependent event. Thanks so much for watching.